Hi, Ms. Myers here, Berea Mid-Park High School Honors Chemistry teacher. This is a vodcast on scientific notation and math using a basic calculator. You can find a copy of this PowerPoint on the Chapter 2 page of our wiki. Our objectives today are to learn how to multiply and to divide numbers in scientific notation with a basic calculator, be able to add and subtract numbers in scientific notation with a basic calculator. Now, if you just have a graphing calculator or a scientific calculator at home, you can pretend it's a basic calculator. On your quizzes and tests all year, you're going to have to use a basic calculator. So we're asking you to understand magnitudes of 10 and how to manipulate those. This is an important skill in science. You also need to be able to adjust the decimal point and exponent of your answer so that you're showing proper scientific notation. And of course, with everything in chemistry, you're going to have to show the correct significant figures and metric units with each calculation. So, complete notes on this PowerPoint as we go through. At the end, we want to see all 4 problems, the sample problems solved, and we want to see every single intermediate math step. So we want to see the calculator answer, we want to see how you decided to manipulate those answers, and the correction of the decimal point. If you put these steps down, it's easier to track where you went wrong. So come to class and know how to use scientific notation properly, how to put a number into correct scientific notation, as well as to mathematically manipulate it. And again, we want you to show those significant figures and proper metric units with all answers. So here's the basic idea. Scientific notation is just a way for us to show really big numbers or really small numbers in an effective way. So everything's based on a base 10 system. And if you look at the second bullet down, it tells you that if you have a positive exponent, that what that means is you're representing the number of times that a coefficient is multiplied by 10. The coefficient being the 5.67 in this particular example. So if you look at the first example, we have 5.67 times 10 to the third. The exponent is the third, and so all this means is that we multiply 5.67 times 10 times 10 times 10, and you can see the answer. A negative exponent is going to reflect the number of times that the coefficient has to be divided by 10. So if you have an exponent of -4, all you're doing is dividing by 10 4 times. So you're getting a smaller number. And really that's all there is to it. One thing you need to remember, though, is that there are specific rules in terms of how to express scientific notation properly. If you look at the coefficient here, 5.62, you'll notice that the coefficient is between 1 and 9.9 repeating. This is always going to be the case. You'd never have a number that's less than 1, and you'd never have a number that's 10 or greater. Now, we always want to write that time sign in the middle of our coefficient and our exponent. And then our exponent, we always want to put 10, and then our negative or our positive exponent. And in chemistry, since we're mostly dealing with measured values, we're always going to use a unit, so we have to learn to manipulate those units. Okay, so let's just look at some simple math. If I asked you to multiply 1,000 by 10,000, some of you would be a little bit stumped. But you would probably recall that really all you have to do is add up those zeros. Likewise, if you were dividing, let's say 100,000 by 100, now some of you might run to a calculator and you might do this, but all you have to do is take the number of zeros in the first number and subtract the number of zeros in the second number, and what you get as a difference is going to be your answer. So this is kind of like the same idea in scientific notation. Now, multiplication and division are a lot easier than subtraction and addition. So all you have to do here is in a multiplication problem, you multiply the coefficients together, you write down what that product is, and then you take your exponents and you add your exponents up. And then of course you're going to take your units and you're going to multiply your units since it's a multiplication problem. With division, you subtract the exponents. So you're going to divide the first number of the coefficient by the second coefficient, record that number on your paper, and then you're going to subtract the exponent. So in this case, it's going to be 6 minus 4. So let me show you what happens here. On the multiplication problem, what we have here is a 4.25 times 1.333. So we're going to start with that, and if you punch that into your calculator, what you're going to get is 5.66525. And I'm not worried about sig figs quite yet. Now the great thing about this product is you can tell that this product is between 1 and 9.9 repeating, so we don't have to adjust the decimal point. Now with the exponents, all I'm going to do is add those up. So you can think about this for a while. If you add 6 and negative 4, you're going to get an exponent of 2. So this is going to be times 10 to the second power. If we multiply our metric units together, then we're going to get a centimeter times a centimeter, which is a centimeter squared. So this is a very simple problem. All we have to do now is look at our number of significant figures in the first coefficient, compare that to the number of significant figures in our second coefficient. So it's 3 sig figs and 4 sig figs, and our rule tells us that what we have to do is go with the least number. So I can keep 1, 2, 3 significant figures. Since the 5 is next to the 6, then I would then round this answer to 5.67 times 10 to the second power, and then of course I can't forget to put my units in. Now if you do the division problem right here, you go ahead and you divide 4.25 by 1.333. Your calculator answer here is going to be 3.188. And I don't know how many places you have in your calculator, but I've got a few more. 297. Now, if you subtract your exponents, you've got 6 minus 4, and of course 6 minus 4 gives you an exponent of a 2. If we're dividing units, what we can see here is since these units are so different, and when we're dividing them, we have to have like units in order to cancel, that we're not going to be able to cancel anything here. So all we do is we just write one unit on top of the other, and of course what you'll see here is you're going to recognize a density unit. Now once again we look at our significant figures, 3 versus 4, and of course we're going to go 3 significant figures, so 3.19, because this 8 here is next door to the 9, we're going to stop right there, times 10 to the second, and of course we have our density unit of grams per cubic centimeters here. So that's a really basic start for multiplication and division. When you're doing these problems, you should go through a checklist. You should always ask yourself, is your math correct? Go back and look at your numbers and just see if they make sense. Then you're going to, after you solve, make sure that your significant figures are correct. Remember your rules. Go back to your book or to your notebook and review those rules if you forgot them. Then of course you need to ask yourself if you're using the proper unit. Okay, now sometimes what's going to happen is you're going to multiply, divide, or sometimes you're going to add and subtract, and then what happens is you're going to notice that you get a coefficient that is less than 1 or 10 or greater. And so what happens here is you get into a little bit of trouble because you now have to move your decimal point so that your coefficient is between 1 and 9.9, and then of course you just can't change your decimal point. You also have to change your exponent. So here's the deal. If you move your decimal point to the left so that your coefficient gets smaller, your exponent has to grow by the same number of powers of 10. As many places as you moved your decimal, that's how much your exponent is going to increase by 10. Now let's say you make the number bigger, you move your decimal to the right so that your coefficient is correct. In this case, what you need to do, since your coefficient became larger, your exponent has to become smaller by the same number of powers of 10. So all you're doing is doing a balancing act. So if you look at these examples here, if you multiply the first example, the coefficients together, what you're going to see is you're going to get a product of 31.160, whoops, this is 1604. You add your exponents up, and that's going to give you times 10 to the 10th power. Your unit is centimeters squared. Okay, so we can see that this 31 is clearly larger than 10. So what we have to do is we just have to move our decimal one place to the left. And so what I'm going to get here is a 3.1. So I'm going to cut my significant figures at the same time so I don't have to go back and do that step and write all these numbers again. Now, if I make this number smaller by 1 power of 10, and I just did because essentially I just divided by 10, then what I have to do is I have to grow my exponent by 1 power of 10. So all I do is I add 1 onto my exponent of 10, and I've balanced things out. I still have the same number, and if you don't believe me, what you can do is you can write both of these values out with zeros, and you can prove it to yourself. Okay? Now, if I'm dividing, let's say I have this particular problem here, and my product, or excuse me, my difference is going to be 0.2611, and I think that repeats. Okay, I'm going to subtract my exponents. That gives me a times 10 to the second power. Now, a meter squared divided by a meter is a meter. So we have a length. Area divided by length gives us a length. Now, I can clearly see I've got two significant figures here, so these are the only ones I'm going to keep. This coefficient is less than 10, so what I need to do here is I need to bump my decimal one place to the right, which essentially is multiplying by 10. Now, if I multiply my coefficient by 10, what that means is I have to divide my exponent by 10. So this answer then would be 2.6 times 10. My coefficient became greater by 1 power of 10. My exponent has to get shrunk by 1 power of 10. And my unit is meters. So addition and subtraction is a little bit tougher. When in scientific notation, with addition and subtraction problems, what we end up with is having to make sure before we add and subtract that our exponents are the same. And this is kind of like when you were in elementary school and you were learning to add columns of numbers up. Remember when you had to line the decimals up? You just couldn't put the numbers on a page and just add them up when the decimals weren't lined up, because it would be absolutely crazy. Well, it's the same thing in scientific notation, but instead of the decimal, what we're looking at is the power of 10. So let's look and see what that means here. If your exponent has to become larger in order for you to add, then remember, your coefficients got to get smaller by the same numbers of powers of 10. And also, if your exponent is going to become smaller, then the coefficient has to become larger by the same powers of 10. Now remember, when you're adding, this is really only going to be temporary. It's only temporary, so don't think, oh wait, I can't write it that way because my coefficient isn't written properly. This is temporary, so don't get blown away by it. So you can see examples here of what we have to do to make our exponents a little bit different. So here's an example for addition and subtraction. So you can see I have two exponents here that are different. Now, what you're going to find is you're going to have to change one of these exponents so that they match each other. So you could change the 3 to a 5, or you could change the 5 to a 3. No matter what you do, it is going to work out. So there's two ways to do this then. So what we would do here is I'm just going to take this 3 and I'm going to make the 5 a 3 also. So I'm just going to show you what happens here if I add that on. Now, if I have an exponent of a 5 and I want to create an exponent of 10 to the third, and then I want to add it up, if my exponent becomes smaller by 2 powers of 10, well, what that means is my coefficient is going to grow by 2 powers of 10. So if that happens, what I'm going to have here is 404